So now, don't say anything bad. All right. So now we're going to complete our square. So like you said, we're going to group our X's and our Y's. I need to change this. Oh, sorry about that. I need to change that to a 28. Sorry about that. Otherwise, we were going to have some trouble. Some of you were thinking ahead maybe, and you could see the trouble we would be in. Did you see it if I didn't change that? Be trouble. Okay, so now I'm ready to complete the square. What goes here?
Oh, I see what it was. Yeah.
What goes here?
Oh, 4.
4. Half of 2, or half of 4 is 2 squares.
25.
Both sides. What goes here?
25.
25. So now I'm going to be able to tell what my center is. What goes in this first parentheses? My X parentheses. X minus 2.
Yeah.
And in my Y parentheses, Y plus 5.
Yeah.
And that adds up to 1. Now, the issue was when I had this as a 38, can you see what would happen if that would have stayed a 38? What very bad thing would have happened?
Would have made it negative.
This number would have been negative. And why does that matter? Because I need to square root that number to get my radius. And if it's negative, that would be an imaginary radius, which would not be good. So that's why I changed it. Okay, so speaking of that, what is my center? 2, -5. Perfect. And what is my radius? 1. The square root of this number, the square root of 1 is 1. Right? Any question about that? You're going to do it again next time. We got it? Okay. Now, this is our parabola. We know it's a parabola because only one of the parentheses is squared. And which one is squared is important to us because that helps us determine which way this parabola will open. And that's important in order to find the focus. So, what can you tell me about which way this guy opens? I'm just going to make a little note. I hear some up and down, and then somebody said down. X squared is up and down. The -8 makes it down. Right?
Right.
So I know in a minute when I start figuring stuff out, I'm going to open it that way. Where's my vertex? 5, -2. And I'm really careful, there it is, 5, -2. I'm really careful that I always have the X number first. No matter how the equation is written, it's always the X number that comes first. You said it opens down. So that means to get my focus, I'm going to go down, right?
Yeah.
And why am I going down too, Hannah? You're exactly right. Why am I doing that?
Divided by 4.
This number right here is 4p. And p is the distance to the focus. That's what p is. It's how far you go to the focus. Well, if 4p is 8, then Hannah says p is 2. And she's right. She solved that little equation. So we're going to start right here. And we're going to go down 2.
-4.
So that was 5, -4. Did it help you to have that quiz on graph paper? Was that at all helpful?
Yeah.
Yeah, it's just hard to write the numbers.
Yeah. Okay. Now, if I came down to for my focus,
You go up to.
then I go up to for my directrix, and I'm tempted to put a point, but I remember it has to be a line. If it were a point, it would be the 0.5, 0, right? But since it's a line that crosses the y-axis, it's going to be y equals 0. And what's my focal width?
8.
Yeah, we're not going to miss that. Please don't ever put negative for the focal width. That's how wide your parabola is. It can't be a negative number, okay? So even though that's negative, I just put positive 8 there. Any question about that? Because you're going to have to do it again tomorrow.
Tomorrow.
Now we will quiz every single class period now.
Woo!
For the rest of the year?
No, just for this unit.
Oh.
How many more days in this unit?
We only have one more
The rest
curve
of
to
the year.
learn, but we have to finish our ellipse, and then we have the hyperbola to go, and then we'll be done. All right.
Is this a ellipse right now?
This is an ellipse. Now, we already started this conversation. We didn't get quite finished with the whole ellipse, all the notes in the ellipse, but we did enough to take a quiz over this. We know how to do this. This is the one where there's more stuff. You have to find the center and the vertices and the major and the minor and the foci. Okay, so let's go one step at a time, because some of this is really easy. Where's the center?
1, -2.
Yes, that is exactly like your circle and your parabola. It's 1, -2. Now, the vertices, we're going to start here, and we're going to count up and down and left and right, and then we're going to connect and make the oval, right? An ellipse is an oval. Do you remember how we count up and, how much do we count sideways? How much do we count up and down? You remember how to do that?
Divide the denominator by 2.
You don't divide the denominator, you square root it. So Nick, I think of it like this. You know in our circle, to get the radius, we took the square root of that number? I think of this as the radius for x. So if I take the square root of that, it's going to be 2, and that means I'm going to go 1, 2 this way, and 1, 2 this way. It's my x radius. Square root the denominator of x, and that tells you how far sideways to go. So what would those 2 points be? You're starting at your center, and you're going back 2.
3. Oh wait, no, that's the other one.
This way would be
-1.
-1, -2. Beautiful. And then this way, you're going forward now. This way would be
3,
-2. Now this will be run up on graph paper for you too. It really helps, I think, when you start counting like this. So that's 2 of our vertices. -1, -2, and 3, -2. That's 2 of them. But there's 2 more, guys, because we not only have to count sideways, we have to count up and down. So now I'm going to look at the 16.
4.
It's under y. Y is up and down. Square root of 16 is 4. So I'm going to start right here and count 1, 2, 3, 4.
1, 2.
And that's 1, 2, James Todd says. And 1, 2, 3, 4.
-6.
1, -6. So those are my other 2 vertices. And then I can connect the dots. Now, I'm not grading your picture. It's just there for us to use as a reference. Now, obviously, if it's an oval, one direction is stretched more than the other direction. If they were stretched the same, it'd be a circle. So, can you see this is the longer stretch? How far is it from top to bottom of that ellipse? 8. Now think that is so simple. You started at the center and you went up and down 4, right? So that would be 8. So your major axis is 8. Then your minor axis, that's the short one, it is 4. Because you started at the center and went 2 units both ways. The focal points, the foci, are always located on the major axis. So sometimes the foci are this way and sometimes they're this way. It just depends on your particular ellipse. I don't have any idea where they are, but they're somewhere on that axis. Remember, I'm not grading your picture. Those points are there for reference. Because I think, even if you don't remember a thing, can get half credit for that problem. Because what do you know about both of these points?
They're
The
both
x
on
is
zero.
1. The x is 1. So you get half credit just by paying attention to the shape. Now, to figure out the y, this is the harder part, to figure out the y, you have to know how far up and down to go. The distance from the center to the focus. Does anybody remember how we find that? Julia?
16 minus 4.
Exactly. The square root of 16 minus 4. Kids, in an ellipse problem, you're going to take the square root of that number and use it. You're going to take the square root of that number and use it. And then you're going to subtract them and take the square root of that number. That is what? Root 12.
2 root 3.
2 root 3. That means I'm going to start right here. That point is down to negative 2, right? And I'm going to go up 2 root 3. So in other words, I don't know what 2 root 3 is. It's some decimal. But I'm going to start at negative 2 and add 2 root 3 to it. Take 2 root 3 steps up. Then what am I going to do down here? So negative 2 is my starting point, and then minus 2 root 3. And those 2 points are your foci. So it's 1 comma negative 2 plus 2 root 3, and 1 comma negative 2 minus 2 root 3.
So we can just keep it like that?
That's how you should keep it, yes. We'll do another example of that, but does anybody have a question about one of those? Yes, Dylan.
Where did you get the negative 2 from?
The negative 2 is the starting point.
okay.
For everything comes from the center.
Okay.
So that's where I'm starting, and I'm going up and down.
I had one question about, how do you know which one's the major and which one's the minor?
Major is longer,
Okay.
so whichever one moves farthest, that's the major. Okay? All right, let's try one more ellipse. The quiz will have 3 problems on it, just like this, but let's practice one more ellipse since that's kind of the new part. Let me switch those because I don't want you to think that number's all right, there we go. All right, this is an ellipse, right? And even if you forget, the directions are going to say find the major and minor axis. That's kind of your clue. This is an ellipse. All right, so here we go. Where is my center?
Negative 1.
Negative 1, 4. So everything starts here. This is where all your counting starts. Okay? So now we need the vertices. That's the like the outsides that we connect to make the shape. So what does this 25 tell me?
5.
5 which way?
Left and right.
Left and right. That's the X number. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, now I need to label those because there's a blank that says vertices, and you need to write all these points in there.
4, 4.
So James Cloud says this is 4, 4. Is he right? Yeah.
Negative 6.
And negative 6, 4.
Yep.
Now, what about this? How do I know how far up and down to go?
Up and down 4.
Up and down 4. So 1, 2, 3, 4 puts me at negative 1, 0.
Yeah.
And 1, 2, 3, 4 puts me at negative 1, 8. Perfect. Now I'm going to connect those. And there's my ellipse, such as it is.
What time's your major one?
So my major axis, those, wait a second, those 4 points right here that I'm drawing circles around, those are your vertices. So in the blank that says V, vertices, those are it, 4 of them. Now, the major axis, Hannah says is 10, is she right? This time it's this way. James?
How many points is like an ellipse probably going to be worth? Because there's like more.
Yeah, I think everything's just gonna be worth 1 point, so I think it's like 11 total. I mean, no, not just this problem, I think the whole quiz is like 11. Yeah. Okay, minor axis,
Hold for 8.
it's 8. Is that okay with everybody? Now, foci, always on the major axis. So that's this way this time. So those foci, these big blue points, are somewhere on the major axis. Seth.
Does that mean your y is always gonna be 1 now?
That means y isn't 1, y is 4. These points are 4 units up. Like if I plotted this, I'd go over and up 4. So you're right, the y's are going to be 4. And I'm not sure what you're getting at, Seth, but I think you're getting at, I'll always know part of that point, and you're right, you will. But think about, if you had graph
last
paper.
problem, you just said like the x's is always 1.
Uh-huh.
I thought that was...
No, this was x is 1 because these points are over 1.
Oh, okay. I thought,
These points are all up 4.
yeah, I thought you just said always 1.
No.
That makes sense.
Depends on what the center is.
What time do we go to lunch?
When I'm ready.
When she dismisses
I
you,
don't know if you forgot.
Is this lunch period?
Yes.
This is apparently the lunch period, which I think is crazy.
Apparently.
But here we go. We gotta finish this. We gotta finish it. So, how far am I going to count over?
Square root of 25 minus 16.
Exactly, Brittany. Thank you. And what is 25 minus 16, Brittany?
that's 9, which is
That's
3.
9. And the square root of 9 is 3. So this one I can actually work out. It's not a radical. So I'm starting right here. And I'm counting over 3. So if you start here at -1 and you count over 3, where would you be? 2. And how about if you counted back 3? No.
Oh wait, no, my bad, 4.
-4, right? -4. We start at -1. This point right here is at -1. And we count back 1, 2, 3, we'd be at -4. So these 2 points circled in blue are your foci. Anybody have a question about that? Quiz tomorrow will have just 1 ellipse, even though we did 2 here for practice. Okay? If you need more practice, well, we've taken notes over this. You have your note problems to practice. You have homework problems to practice. You can always come back and redo these. Right? All right. Let's see what time is it. All right, let's go to lunch. And let's have everybody back at 12:04. 12:04.
Round it up.
No, round it down. 12:04, everybody back.
I think I killed that thing. I think I killed it.
Does that mean good?
Yes.
Okay.
I think I got 100.
You think you got